Welcome students, welcome to Arith. Now, in the previous class, we have studied the addition and subtraction of the vectors. Now, we'll go for the resolution or component of vectors. So, resolution or components. What is the meaning of resolution of a vector? Now, resolution is the opposite process of addition. So, in addition of vectors, a number of vectors are represented as their resultant or a single vector. So, if there are three vectors A, B and C, then in addition we write that R equal to A plus B plus C. This is called addition of vectors. Now, in resolution, let there is a single vector R. We represent it as the sum of a number of vectors. So, we can write R equal to A plus B. So, we can say A and B are the components or resolution of the vector R. So, resolution is just the opposite process of addition of vector. In addition, a number of vectors are represented as a single vector. In resolution, a single vector is broken into a number of vectors. Now, here we can write R equal to A plus B. So, A and B are the resolutions of R. Now, if this vector is C, this vector is D. Then also we can write R equal to C plus D. But here A, B and C are three vectors. Then the resolution is the single vector R. So, addition of vector is always unique. Vector addition is always unique. The addition of number of vectors is just a single vector and it cannot be changed. But the number of resolutions is infinite. We can make as many number of vectors here. If it is E, F, G, then we can write E, F and G are resolutions of R or components of R. So, the number of resolutions is infinite. It is not unique. There are a number of resolutions of a single vector possible. So, what is resolution? It is the opposite process of addition of vectors. In resolution, a single vector is represented as the sum of a number of vectors. And vector addition is unique, but resolution is infinite. There are a number of infinite possible combinations for a single vector R. Now, next we will go for resolution of a vector in a plane. So there are two possibilities. One is along rectangular components, second one is along oblique components. First we will go for orthogonal or rectangular components. Now, there are two axes, x-axis and y-axis. This is a single vector R. It makes an angle theta with positive direction of x-axis. Now, draw a perpendicular here and here. This is A, this is B. Now, this vector, it is called, this vector OA is the x component of R, represented as Rx. And this is OB, this vector is y component of R, written as Ry. The unit vector along x-axis is I cap and along y-axis it is j cap. Now, Rx will be R cos theta, Ry will be R sin theta. So we can write r equal to root over of rx square plus ry square, and tan theta equal to ry by rx. So if rx and ry are given, we can calculate r and theta using this formula. Now, if r and theta are given, then we can say rx equal to r cos theta, ry equal to r sin theta. Now, we can write vector r equal to rx I cap plus ry j cap. So, r will be rx. Instead of rx, we can write r cos theta I cap plus r sin theta j cap equal to r common cos theta I cap plus sin theta j cap. That implies vector r by magnitude of r equal to cos theta I cap plus sin theta j cap. But vector r by magnitude of r, that is equal to r cap. So if a vector makes an angle theta with positive direction of x-axis, then the unit vector along the direction of r will be cos theta I cap plus sin theta j cap. So next we will go for addition using components. So let us consider there are a number of vectors a1, a2, a3 up to an. Now a1 makes an angle theta 1, a2 makes an angle theta 2, a3 makes an angle theta 3, like that an makes an angle theta. So now what will be their resultant? Let their resultant is r. So r equal to a1 plus a2 plus a3 up to an. Now, how we can obtain this resultant using the components? Now, if r has an x component rx, then rx equal to a1x plus a2x plus a3x up to anx. So we can write rx equal to summation of ai cos theta I. That means a1 cos theta 1 plus a2 cos theta 2 plus a3 cos theta 3, like that. Like that. ry will be summation of ai sin theta I. So now r equal to root over of rx square plus ry square. And if r makes an angle theta with positive x-axis, then tan theta equal to ry by rx. So in this way, we can find the resultant using resolution. If a number of vectors are acting simultaneously at a point, then resolve all the vectors into their x components and y components. Rx will be the summation of all x components, ry will be the summation of all y components. So r will be root over of rx square plus ry square, and tan theta equal to ry by rx. Now, if it is given in the direction, just remember, in a plane, if you are drawing orthogonal components, then this represents north, this is south, this is east, this is west. Now, let this angle is 45 degree. Now, if you measure from this side, this is called north of east. If you measure the angle from this side, this is called east of north. If you measure this side, this is called west of north. This is called north of west. Like that. This is south of west. This is west of south. This is east of south. This is south of east. Now just check. If a vector is acting along 30 degree north of west, then this is north, west, south, east. So 30 degree north of west. North of west means you have to measure from west towards north. So from west towards north, this angle will be 30 degree. So 30 degree north of west means this direction. Now, if I say 20 degrees south of east, south of east means from east towards south 20 degree. This will represent 20 degree south of east. So, if the question is given like this angle north of west or south of east, you will draw like this. Then find the components. Okay. So, next we will go for oblique components. So, let this is a vector R. Now, there are two oblique axes here. Now, this axis makes an angle alpha and this axis makes an angle beta. Now, let the component of R are P and Q along these two oblique axes. Now, how to find the oblique components P and Q? Just remember P by sine beta. P is here. So, P divided by the angle between R and Q equal to Q divided by sine alpha. That is the angle between R and P equal to R divided by sine of angle between P and Q. That is equal to alpha plus beta. So, using this formula we can obtain oblique components. Now, just check for Q. Sine alpha, sine beta can be greater than or less than sine alpha plus beta. That's why R can be greater than P, greater than Q, or R can be less than P and Q. So, we can say oblique components of a vector can be greater than or less than the vector. So, oblique components of a vector can be greater than the vector, can be less than the vector, depending upon alpha and beta. But orthogonal components or rectangular components are always less than the vector. So, oblique components of a vector can be greater than or less than the vector, but orthogonal or rectangular components are always less than the vector. And next thing, number of oblique components can be infinite because we can take any value of alpha and beta. But orthogonal components, this is unique because for to given axis R make a fixed angle with x and y, but oblique components, number of oblique components may be infinite, okay? Because the value of alpha and beta can be infinite. And this orthogonal component, it is a special case of oblique component. For orthogonal component, both alpha and beta equal to 90. Alpha plus beta equal to 90 degree. So if you put P by sine beta equal to Q by sine alpha equal to R by sine 90, that is equal to 1. So orthogonal component is a special case of oblique component. Now here just remember this triangle. We all know that 3, 4, 5 are a Pythagoras triple. So if the sides of a triangle are 3, 4 and 5, it is always a right angle triangle. Now the opposite angle of 5 is 90 degree. The opposite angle of 3 is 37 degree and the opposite angle of 4, it is 53 degree. Now from this triangle we can write sine 37 degree equal to 3 by 5. It is equal to cos 53 degree. Like that, sine 53 degree equal to 4 by 5. It is equal to cos 37 degree. Like that, tan 37 degree. It is equal to 3 by 4. It is equal to cot 53 degree. And tan 53 degree, it is equal to 4 by 3. It is equal to cot 37 degree. So if 3, 4, 5 represents a right angle triangle, the opposite angle of 3 is 37 degree and opposite angle of 4 is 53 degree. So just remember this triangle. This is very useful to find oblique components. For example, if the question asks a vector has a magnitude 60 Newton. Now find its components if both the components make 37 degree with the vector. Now this is R, this angle is 37 degree, this angle is also 37 degree. So this is P, this is Q. Now we can write P by sine 37 equal to Q by sine 37 equal to R by sine 37 plus 37, that is equal to sine 2 into 37 degree. Now P equal to Q equal to R by, we can put 2 sine 37 degree into cos 37 degree into sine 37 degree, multiplying each term with sine 37. Now the value of R is 60, so we can put 60 here. Now sine 37 will cancel out. So it will be 30 by cos 37, that is equal to 4 by 5. Now if we take 5 here, this is 150 by 4 Newton. So 150, the rectangular, the components are 150 by 4 Newton. So in this way we can find the oblique components of a vector. Next we'll go for orthogonal components in space. So now consider 3 mutually perpendicular axes. This is x-axis, this is y-axis, this is z-axis. Now let this is a vector r. Now unit vector along x-axis is I cap, along y-axis it is j cap, and along z-axis it is k cap. Let the angle between r and x-axis is alpha. The angle between r and y-axis is beta, and the angle between r and z-axis is gamma. Then the x component Rx equal to R cos alpha. That implies cos alpha equal to Rx by R. Ry equal to R cos beta. That implies cos beta equal to Ry by R. Rz equal to R cos gamma. So cos gamma equal to Rz by R. Now R will be equal to root over of Rx square plus Ry square plus Rz square. R will be equal to Rx square plus Ry square plus Rz square. Now this is called L, this is M, this is N. Cos alpha is called L, cos beta is called M, cos gamma is called N. These are called direction cosines. L, M and N, that is cos alpha, cos beta, cos gamma are called direction cosines. Now you all know that cos square alpha plus cos square beta plus cos square gamma, that is equal to 1. Sin square alpha plus sin square beta plus sin square gamma, this is equal to 2. So what will be R? R equal to R cos alpha I cap. So we can write Rx I cap plus Ry j cap plus Rz k cap. So we can write it is equal to R cos alpha I cap plus R cos beta j cap plus R cos gamma k cap equal to R common cos alpha I cap plus cos beta j cap plus cos gamma k cap. That's why if we take R this side, vector R by R, that is equal to R cap, it will become cos alpha I cap plus cos beta j cap plus cos gamma k cap. That means it is equal to Li cap plus Mj cap plus Mk cap. So if L, M and N are the direction cosines, then the unit vector will be R cap equal to Li cap plus Mj cap plus Nk cap. This is all about orthogonal components in a space. Next, we will go for position vector. Now, this is our coordinate axis. Now, consider a point P. It has a coordinate x, y and z. Then, the position vector of P, this is, we can write P vector or OP vector. It is equal to xi cap plus yj cap plus zk cap. So, the magnitude of the position vector will be root over of x square plus y square plus z square, and the unit vector p cap, it will be equal to x by root over of x square plus y square plus z square I cap plus y by root over of x square plus y square plus z square j cap plus z by root over of x square plus y square plus z square k cap. This is the unit vector along the position vector. So, this term x by root over of x square plus y square plus z square, this is cos alpha, this is cos beta and this is cos gamma. This is all about position vectors. Next we will go for displacement vector. Now, consider a particle moves from P to Q. Then this PQ will be the displacement vector. Now, this is the position vector of Q. Let P has a coordinate x1, y1, z1. Q has a coordinate x2, y2, z2. Then in the triangle OPQ, we can write OP plus PQ equal to OQ. So PQ, the displacement vector PQ equal to OQ minus OP. That is equal to position vector of Q minus position vector of P. So displacement vector from P to Q, it is equal to position vector of final point minus position vector of initial point. So its magnitude will be, if we solve it, it will become x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So its magnitude will be root over of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. This is the magnitude of displacement vector. So students, in this class we have studied the resolution of vectors, that is the resolution of vector in a plane which is possible along orthogonal axis or oblique axis. Then we notice that the component of a vector in oblique components, it can be greater than or less than the vector. But orthogonal component, it is the component is always less than the vector. Like that, orthogonal vector in a plane, the components of orthogonal vectors in a space are also less than the vector. Then we studied position vector and displacement vector. Objective questions I will give in the description. Go through them. If any doubt, contact our Telegram link given in the link. So thank you for the classes.